Hello everyone. Today our team is going to present a presentation on use of machine learning and deep learning to predict the outcomes of Major League Baseball matches. Major League Baseball, that is MLB, is a professional baseball organization and the oldest professional sports league in the world. It has the highest second average spectators per game when compared to the other sports league. The popularity of streaming media has helped to promote the interest in large sporting events such as MLB. So the details and outcome of each game and performance of each player have become a daily topic of interest for many fans, giving rise to many business opportunities. In 2017, each MLB team generated an average of 300 million USD, which is equivalent to the generated by other highest ranking teams in North America. In 2019, a team was valued at around 1.8 billion USD and they had an increase of 8% from the previous year. So the half of the MLB teams were valued more than 1.5 billion and the average revenue generated by the teams was like more than 330 million USD. Michael Lewis' book Moneyball, The Art of Winning an Unfair Game in 2003 became very popular and it was specialized for the use of data analysis tools in the field of sports. Moneyball shows how statistical data analysis can be used in the field of baseball to help the player selection, game management, and thus helping to win a game. Many scholars now use baseball references, Fangraphs, and other similar websites to collect the statistics of each team and each player, and then they apply machine learning methods and deep learning methods to predict the outcome of the MLB matches. There are different methods used to predict the outcome of a baseball, such as a two-stage Bayesian model used to predict the division winner in MLB. A researcher Chen used logistic regression and artificial neural networks to build a prediction model for MLB matches. The researcher Valero used machine learning methods based on artificial neural networks, support vector machine, decision tree, and nearest neighbors algorithm to predict the outcome of MLB matches. Alfric used random forest algorithm, extreme gradient boosting, a linear model, and a boost logistic regression to construct the models of predicting the outcome of baseball games. Researcher Chen proposed a self-encoding two-dimensional neural network to predict the performance of NBA players and the outcome of matches. The results were compared to that of the result obtained by MLB matches using artificial neural network. The convolutional neural network is one of the most popular deep learning method used and it was successfully used to solve the machine learning problems. In the later stage, the accuracy of prediction was given more importance. The researcher Howard and Job studied the accuracy of sports outcome. So the prediction of American football game matches was around 90%, cricket match was around 85%, the accuracy of outcome of baseball matches was relatively low, around 50 to 60%. So we are using machine learning methods such as artificial neural networks, 1D and SVM methods to predict the outcome of MLB matches.
So baseball stats have been around for around 150 years or so, and those include things like home runs, runs batted in, stolen bases, kind of your basic baseball stats. And in the 1970s, sabermetrics were introduced, which can kind of be thought of as like a more advanced form of stat taking, and those include things like on base percentage, on base slugging, your ERA or your earned run average. And previous studies have used websites that track these data, and these websites are Baseball Reference, Fangraphs, Sean Layman's database, RetroSheet, but this study uses Baseball Reference for its data source. And these data sources have been used to predict pitcher performances, predict win-loss outcomes using variables like hitting, pitching, defensive data. And then also we have some dedicated Red Sox and Yankees fans that wanted to predict some win-loss outcomes and they used data from the starting pitchers only, mainly just because the starting pitcher for an MLB team is seen as one of the most important aspects of the team. But this study did both. So this study is using data from starting pitchers and from pitchers lumped in together from starting relievers. Um, so all the pitchers. So they separated those two datas out. So in previous studies, feature selection was done using these following methods. So the first one, Weka, this is just a machine. It's a collection of machine learning algorithms, and its purpose is for data mining. So this study by Chowinski selected the top 5 variables of 15 for its prediction model, and the study by Valero selected 15 of the 60 variables for the prediction model, and this is basically just they're saying that these 5 and these 15 variables were the most important out of all of the variables. And then the logistic regression, which we've learned about in class, they used to calculate the variable importance, and a relative importance of 80% or higher were selected for the prediction model. And then XG boost, which is extreme gradient boosting, was used to rank the features according to their importance by study by Elfrink. This study uses relief attribute eval, which we have our definition there provided, but again, it's another way of determining the importance of the variables, and it helps us and enables us to select our features. When looking at the results of the previous studies, they've been able to predict outcomes of NHL games with greater than 90% accuracy, which is very good. And they've been able to predict outcomes of NBA games with an accuracy greater than 90%. So I know a lot of gamblers that would love those odds. Also, as far as the MLB goes, which personally I think the MLB might be the hardest sport to predict, just because I feel like there's a lot more randomness. It's much harder to win a game in the MLB, I think. That's just my personal feelings. Don't let that get in the way of what the data says. But they've been able to predict a division winner of the MLB, and they used the games from the 2001 regular season, and they used a Bayesian model. I'm not sure if I'm pronouncing that correctly, but basically it uses parameter knowledge, and the statistical model is updated with the observed data. And then again, we have the Red Sox Yankees study, and they were able to use a artificial neural network, which is named that way because it's supposed to act like neurons do. And they predicted the win-loss for the Yankees and Red Sox with 72.2% accuracy, which, considering it's the MLB, I think that's pretty darn good. And then lastly, they use a support vector machine to predict wins and losses in the MLB with 59.6% accuracy. This particular study, is using a one-dimensional convolutional neural network, which is used to identify complex patterns. Also, it's using an artificial neural network and, again, an SVM to construct its prediction models.
The outcomes of this project include predicting the outcomes of Major League Baseball matches during season games using deep learning and machine learning methods with the following steps. Separate the 30 teams into 2 data sets, the first which contained batting and the starting pitchers, and whether they were home or away in that match, and the second contained data on batting and all pitchers, and if they were home or away in that match. Then the data was normalized into features, and features were selected. The chart on the right demonstrates the flow of data as it moved to feature selection. Data collection to predict the 162 games in the 2019 season started with collecting data from 4,858 games within the Major League Baseball games. The data was collected from Baseball Reference, a website that tracks data on items like batting, pitching, and games. Batting was used as the selection of the total group data for each game. Pitching was categorized into two categories, with the starting pitcher being classified as SP and the relief pitcher being classified as RP, with the starting pitcher being the person that starts the game and the relief pitcher being the one that relieves that pitcher. The games were classified in a couple different ways, with them being home, away, and the team that was opposing them in that game. Both data sets include one variable for home and away teams, denoted as x1, y as the output of win or loss. The first data set contained 32 variables, which are batting variables, 13 in total, denoted as B1 through B13, and starting pitcher variables, 16 in total, denoted as SP1 SP through SP16. The second data set included 32 variables, batting variables, 13 in total, denoted as B1 through B13, and variables for all pitchers, 18 in total, denoted as P1 through P18. The last step before selection are inputting into a prediction. To establish a benchmark for sequential analysis, min and max normalization was used to eliminate the relevant variance of each variable. This was done by assigning a value between 0 and 1 according to the equation shown below. X min equals the minimum and X max equals the maximum, resulting in 0 or 1. Feature selection is used to reduce the number of features to increase the prediction accuracy of machine learning. Feature selection methods are classified as wrapper, filter, and embedding methods. Wrapper evaluates a certain machine learning algorithm to find optimal features. It has high compute times for a large data set and a high chance of overfitting. Filter, the one used in this study, uses a generic set of methods which do not incorporate a certain machine learning algorithm. They're faster than wrapper methods and less prone to overfitting. Embedded methods embeds features during model building processes by observing each iteration of the model training. Sets between filter method and wrapper methods on speed and are used to reduce overfitting by penalizing the coefficients of the model that are being too large. Relief F was used in the feature selection method in this study. It was based off the relief algorithm. The relief algorithm was first developed by Kira and Randall for use of discrete and continuous attributes. However, in 1994, Kaneko then proposed an extension of the relief algorithm called Relief F for use of noisy or incomplete data. The algorithm could be applied to multiple classification problems and regression problems. Relief F repeatedly obtains samples from the training set and calculates the difference between instances to find the nearest neighbors. The basic difference between Relief F and Relief is the selection of K, hits and misses, moreover, compared with Relief to Relief F. Relief F is more robust against noise. This will be shown on the next slide. The pseudocode for the Relief F algorithm is shown on the right. WA represents the weight of the feature A. M represents the number of cycles of random training examples. RI represents a randomly selected example. HJ represents the nearest hit and the search for the nearest K neighbors of the same class. MJC represents the search for the nearest K neighbors for each category. PC represents the portion of each category. P class RJ represents the portion of each randomly selected instance belonging for the class. And then WA is updated according to the values of RI, HJ, and MJC. And then finally, the appropriate features are selected according to the weights. All this is shown in the 10 steps on the right. But basically, this algorithm is used to find the best features to select for the machine learning task.
Hello everyone, my name is Carlos Pacha. I will be talking about how the prediction model was constructed. Well, in this study, 3 prediction models were constructed. The first one is the one-dimension convolutionary neural network. The second one is the artificial neural network, and the third one, support vector machine. When constructing the prediction models, the original variables prior to feature selection were input into the one-dimensional convolutionary neural network, the ANN and SVM. The variables after feature selection were the input into ANN and SVM. 5-fold cross-validation was employed to determine the prediction accuracy of the models. On the next slides, I will be talking about the 3 prediction models. Now I will be talking about the first method, the one-dimension convolutionary neural network. This is suitable for analyzing signal and time series data. Keras was used with Python to construct this IDCNN model. Well, as we can see in the figure number 5, there were 8 layers in total. A one-dimension convolutional layer, a maximum pooling layer, a one-dimension convolutionary layer, another maximum pooling layer, a dropout layer, a fully connected layer, another dropout layer, and an output layer. As we can see, this is how the architecture of the model was designed. Continuing with the IDCNN prediction model, the sigmoid activation function was used for solving binary classification problems. The equation is f of x equals 1 over 1 plus e to the power of negative x. The following table shows the parameter settings. It also shows the number of convolutional kernels, also called filters. They were set to 16 and 32 in the 1D convolutional layer. The convolutional kernel size was set to 3, the maximum pooling layer window size was 2, the strides were all set to 1, the padding was set to the same value, which means that the input and output data are the same size, and the dropout was set to 0.2. In this slide, we will be talking about optimization. The optimization in neural network learning implies determining the ideal combination of parameters with minimal loss. In this study, Adam and RMS-Prop with the grid search method, grid search CV, were using Python to determine the most suitable optimizer for this model, and the loss function was set to binary cross entropy to deal with the problem of 2-group classification. In this case, the batch size was set to 10, 20, and 30, and the epochs were 50, 100, and 150 with 5-fold cross-validation. Now I will talk about another prediction model, that is the artificial neural network. Well, the artificial neural network are some of the most common use models for motion prediction in machine learning. A basic ANN comprises an input layer, a hidden layer, and an output layer. The number of hidden layers depend on the complexity of the problem. The higher the number of hidden layers, the slower the learning rate. In studies conducted by Chen and Soto Valero, one hidden layer was used to construct a model for predicting the outcomes of MLB matches. In this study, on the other hand, a match result is classified as nonlinear and binary, which means win or loss. Therefore, the sigmoid function was used as the excitation function of the neuron in the input layer. For this study, an ANN prediction model was constructed in Python. For the dataset 1 and dataset 2, the input variables in the input layer were 30 and 32 respectively, and the number of neurons in the hidden layer was set to 16 and 17 respectively. In this study, the output layer was the game win or game loss, 1 or 0. A dropout layer was added after the hidden layer to prevent overfitting. The dropout value was set to 0.1. The kernel initializer, which is the initialization method, was placed in the input layer and output layer. The initialization method includes zeros, ones, random normal, glored normal, and he normal. They used cross-validation in Python along with grid search CV to determine the most suitable initialization method for this model. The sigmoid function was set as the activation function for neurons in the output layer. In terms of optimization in this study, the optimizer setting was the same as the one in one-dimensional convolutionary neural network. Adam and RMSprop were employed with grid search CV to determine the most suitable optimizer for this model. The loss function was set to binary cross entropy. The batch size was set to 10, 20, and 30, and the epochs were set to 50, 100, and 150 with 5-fold cross-validation. The third and last prediction model is the support vector machine, an SVM which is based on a statistical learning theory, is a supervised machine learning model, and it is used to solve problems such as binary classification, multi-classification, and regression problems. An SVM constructs a hyperplane as a decision boundary in between two categories and establishes a clear distinction. Also, in this study was employed the most basic linear kernel and the popular nonlinear RBF kernel to construct the prediction models. In this model, grid search CV was used in Python to set parameters for the collected dataset. Table 4 lists the accuracies obtained with the linear kernel for various C values of 1, 10, 100, and 1000, and the RBF kernel for gamma values were set to 0.0001, 0.001, 0.1, 1, 10, 100, and 1000, and C values set to 1, 10, 100, and 1000. Five-fold cross-validation was performed. The table indicates the ideal parameter setting for the data set 2. The RBF SVM with a C value of 1000 and gamma value of 0.1 attained the highest accuracy of 93.9%. Now I will talk about the performance evaluation index in this study. Well, a binary confusion matrix was generated in the win-loss prediction, and the evaluation index was derived on the basis of the actual results and predicted results. True positive is TP, which indicates that a win has been correctly predicted as a win. False negative, which is FN, indicates that a win has been incorrectly predicted as a loss. False positive FP indicates that a loss has been incorrectly predicted as a win. And true negative, also as a TN, indicates that a loss has been correctly predicted as a loss. Now we can see here the table number 5, and that resumes the explanation. Lastly, in the SVM prediction model, the accuracy was calculated using the following equation. That is, accuracy equals to true positive plus true negative over true positive plus false positive plus false negative plus true negative. That equals to our accuracy.
On this slide, we are going to discuss the dataset 1 prediction results obtained using one-dimensional convolutional neural network, or 1DCNN. Dataset 1 contained 30 variables. The data was first normalized and then divided into a dataset into training data, 80% of the data, 3,886 data points, and a testing dataset, which was 20% of the data and 972 data points with 5-fold cross-validation. For one-dimensional convolutional neural network, the average accuracy rate was 91.44%. Out of 972 matches, 482 matches were correctly predicted wins. 30 matches were incorrectly predicted losses. 396 matches were correctly predicted losses, and 64 matches were incorrectly predicted wins. A total of 879 matches were predicted correctly, and 94 matches were predicted incorrectly, yielding an accuracy rate of 90.33%. In this slide, we will discuss the same dataset 1, but this is predicted using artificial neural networks, or AN. The hidden layer is set to 16 with grid search CV. Kernel initializer is set to glow route uniform. Optimizer is RMS prop, and the epochs are 150, and the batch size is 10. The average accuracy rate is 92.02%. Out of 972 matches, 446 matches were correctly predicted wins. 66 matches were incorrectly predicted losses. 440 matches were correctly predicted losses, and 20 matches were incorrectly predicted wins. A total of 886 matches were predicted correctly, and 86 matches were predicted incorrectly, yielding an accuracy rate of 91.15%. And these were the results obtained without a feature section. Next, we'll talk about the results obtained with the feature selection. So results obtained with the feature selection, the hidden layer is set to 16 with the grid search CV. Kernel initializer is set to glow route uniform. Optimizer is atom. The epochs are 150. The batch size is still 10. Average accuracy rate is 92.06%. Out of 972 matches, 475 matches were correctly predicted wins, 37 matches were incorrectly predicted losses, 420 matches were correctly predicted losses, and 40 matches were incorrectly predicted wins. A total of 895 matches were predicted correctly, and 77 matches were predicted incorrectly, yielding an accuracy rate of 92.08%. Next, we're going to discuss support vector machine prediction results for dataset 1 without feature selection and then with feature selection. So without feature selection, the classification accuracies of the 972 matches are 91.26%, 90.65%, 91.56%, 92.08%, and 91.26%. The average accuracy rate is 91.36% using the RBF support vector machine with C setting of 100 and gamma of 0.1 for dataset 1. Out of 972 matches, 432 matches were correctly predicted wins, 51 matches were incorrectly predicted losses, 455 matches were correctly predicted losses, and 34 matches were incorrectly predicted wins. A total of 887 matches were predicted correctly, and 85 matches were predicted incorrectly, yielding an accuracy rate of 91.15%. For the results obtained with feature selection, the average accuracy rate is 91.94%. Classification accuracies of the 972 matches were 90.74%, 91.16%, 92.28%, 91.36%, and 94.14%. Out of 972 matches, 444 matches were correctly predicted wins, 43 matches were incorrectly predicted losses, 438 matches were correctly predicted losses, and 47 matches were incorrectly predicted wins. A total of 882 matches were predicted correctly, and 90 matches were predicted incorrectly, yielding an accuracy rate of 90.74%. For the next few slides, we'll discuss the same models, but with dataset 2. Dataset 2 contains 32 variables compared to datasets 1, 30 variables. For dataset 2, the data was first normalized and then divided into training dataset, which was 80% of the data, 3,886 data points, and then a testing dataset, which was 20% of the data, which was 972 data points. For the one-dimensional convolutional neural network, the accuracy rate was 93.40% using optimizer RMS prop. Epic was set at 100 and batch size was 30. Out of 972 matches, 483 were correctly predicted wins, 29 matches were incorrectly predicted losses, 427 matches were correctly predicted losses, and 33 matches were incorrectly predicted wins. A total of 910 matches were predicted correctly, and 62 matches were predicted incorrectly, yielding an accuracy rate of 93.62%. In this slide, we'll discuss artificial neural networks and dataset 2. So the hidden layer was set to 17 with grid search CV. Kernel initializer is set to be uniform. Optimizer's atom, the epochs are 150, batch size is 10. The average accuracy rate is 93.61%. Out of 972 matches, 481 matches were correctly predicted wins, 31 matches were incorrectly predicted losses, 435 matches were correctly predicted losses, and 25 matches were incorrectly predicted wins. A total of 916 matches were predicted correctly, and 56 matches were predicted incorrectly, yielding an accuracy rate of 94.24%. Next, we'll discuss dataset 2 using AND, but with feature selection. So with feature selection, the hidden layer is set to 16 with grid search CV, kernel initializer set to glue route uniform, optimizers atom, epochs are 150, batch size is 10, average accuracy rate is 94.18%. Out of the same number of matches, 972, 474 were correctly predicted wins, 38 matches were incorrectly predicted losses, 441 matches were correctly predicted losses, and 19 matches were incorrectly predicted wins. A total of 915 matches were predicted correctly, and 57 matches were predicted incorrectly, yielding an accuracy rate of 94.14%. 0.03%, 93.93%, 94.65%, and 93.52%. Out of the 972 matches, 458 were correctly predicted wins, 24 were incorrectly predicted losses, 462 matches were correctly predicted losses, and 28 matches were incorrectly predicted wins. A total of 920 matches were predicted correctly, and 52 matches were predicted incorrectly, yielding an accuracy rate of 94.65%. Next, we will discuss the prediction model results comparison between all three prediction models between dataset 1 and dataset 2. So for dataset 1, the prediction accuracies of the AND model were 92.02% and 92.06% before and after feature extraction, respectively. The prediction accuracies of the SVM were 91.36 and 91.94% before and after feature extraction. The prediction accuracy of the 1DCNN was 91.44% for dataset 1. Although the accuracy of the 1DCNN was slightly lower than the accuracies of the AN and SVM after feature selection, the prediction performance of the 1DCNN was slightly higher than that of the SVM before feature selection. For dataset 2, the prediction accuracies of the AN were 93.91% and 93.99% before and after feature extraction. Prediction accuracies of the SVM were 93.9 and 94.16 before and after feature extraction. The prediction accuracy of the 1DCNN was 93.4% for dataset 2. The three models exhibited similar prediction performance. The prediction accuracies obtained with dataset 2 were higher for all models, which means that using the data of all pitchers is better than using the data of only the SP. Although the performance of the SP during a game is very important, the performance of the RP also must be considered to obtain more complete game information and thus more accurate prediction of the outcomes of the matches.
In this slide, we're going to talk about conclusions and suggestions. We predicted the outcomes of MLB matches by collecting the match data of 30 teams in the 2019 season and using 1DCNN, ANN, and SVM prediction models. The prediction result indicated that 1DCNN, ANN, and SVM models achieved higher prediction accuracies when the data of all features were considered than when only the data of the SP were considered. The three prediction models proposed in this study all achieve high prediction performance and can be used to provide some reference information for fans, team managers, and baseball enthusiasts. What's the contributions of this study? This is the first study to use the 1D CNN model to predict the outcomes of MLB matches. Unlike machine learning models, the 1D CNN model automatically extracts features. This study established two data sets to compare the accuracy of match outcomes prediction when only data on this SP were considered with that when data on all the features were considered. The prediction results demonstrate that using the game data of features yields higher accuracy. This study used data of hitters and features from baseball-reference.com. What's the limitations of this study? Most related studies have collected more than 5 years of match data to construct the prediction models, but this study only used data from 2019. Only one feature selection method was used in this study. So the performance of the prediction models when other feature selection methods are used remains unknown. The adjustments or modifications of the CNN model are encouraged to improve the prediction accuracy. Future research should consider including data on tactical strategy or measure of individual player performance to improve the prediction accuracy of MLB match outcomes. Thank you.